Okay, greetings fellow soldiers and anybody else who might be watching this, Mogers, whatever. It's me, Voltor again, and I'm back, and I've got a project going on here, as you can see. I've got most of the hard stuff taken care of. There's still some hard stuff left, but all the soldering's been done. This, of course, is a Peavey amplifier. And just to kind of show you what I'm doing here, the old speaker that used to be in that amplifier was this piece of crap. Of course, I've got it in a box because it's still a good speaker. Look like this. Now, it's not a bad design. It's got a long throw woofer with foam surround, kind of a foam rubber, composite cone. This is the problem here, the coaxial design. You lose a lot of sound quality with that. The woofer cone has a tendency to beat up against the tweeter, and these leads rattle, and you get all kinds of noises that shouldn't be there. So this design is not only going to improve the bass and the treble, but it's also going to improve the sound quality overall. So what I've got here is a crossover from a pair of computer speakers that were built by Klipsch. I was initially worried that they weren't going to be able to handle the power that this amplifier is putting out, but it turns out that these capacitors are rated for 100 volts and this thing only puts out 20. So we're good. Also, we have the tweeter. This little guy is going to go right in there, and this wire will be soldered onto these terminals on the back, plus and minus. And we have plus and minus. And like I said, all the soldering's been done already. Plus and minus. And plus and minus here. This particular amplifier has a reverb tank, which kind of worries me that the springs might not be strong enough and the preamp might not be strong enough to handle the extra power that this is putting out. But quite frankly, I'm not too worried about it. I don't really use the reverb much anyway. So let's get started, shall we? What I've already done is mapped out where the screw holes are going to go on the cabinet here. I've also mapped out an X, and you're probably wondering why I mapped out an X. This is why I mapped out an X, because I'm going to cut a hole this big around in here with this. Kind of a steampunk way of doing it. A not so steampunk way of doing it would be to, well, the way that I'm going to make the pilot hole. So we'll just go ahead and make the pilot hole right quick. As soon as I can find that drill bit. There we go. And there's always two ways of doing things. There's the right way, which works, and there's my way, which also works. It's just unconventional. Okay, there's our pilot hole. And a lot of dust it did create. That's okay. I'll vacuum when I'm done. Now, this is called a brace and bit. And it was never meant for plywood, apparently. This is going to take a while. Whew. Okay, I'm back. That only took about 5 minutes, actually. I'm sure you didn't want to watch me struggle with all that. I had to take my shirt off. It got too hot. Whew. Okay, so the hole's cut. You gotta get rid of some of that dust and debris. This is what I cut out. And as you can see, it works out pretty nicely. Just takes a lot of patience, a lot of time, and a lot of muscle to work a brace and bit. So let me get this cleaned up and I'll be right back with you.